The next topic we're going to talk about is power electronics. And so for this topic, we're going to be switching to our Analog and Mixed Signal Electronics textbook by Carl Stephen. And so what is power electronics? And so in general, we can say our power electronics is when either the output from our circuit or when the load that we're controlling with some system exceeds a power of about 1 watt. So, or our load controlled by the system. So one of these two cases, in either case, if our power is exceeding approximately 1 watt, we then say we're dealing with power electronics. And so of course this 1 watt is not necessarily a hard definition. You'll see different things in different places, but for this textbook, this is our approximate delineation between power electronics and just general electronics. And so our area of power electronics we can actually subdivide into other categories. So power electronics in itself is very broad. So the first sort of category, which is what we're going to focus on in this class, is power supplies. And so we're going to talk about throughout the class a lot of different aspects of power supplies. But ultimately we can think of various types. We either have an AC source coming in, we're converting that to some DC value. We could have the opposite, so that would be a rectifier, and so we'll talk about that briefly in a later video. The opposite case, if we have a DC input and we want an AC output, and so something like that might be relevant if we have, for instance, a solar panel that we want to connect to the grid. We would use an inverter, so that would be our power electronics in that case. Something that we're going to focus on a little more later on, though, is what if we have a DC input that we want to take to a different DC level. And so those would fall under the category of DC-DC converters. And then, of course, we could also go from AC to AC, and we're not going to focus on that too much. Another big area that is discussed in the textbook, but we're not going to have time to get to, is power amplifiers. And so essentially these are going to be similar structures as to the amplifiers that we've seen before, but if you read through, you'll see that there's some special considerations when you're dealing with higher powers. So again, in this class, we're going to be focusing more on the power supplied side of things. And so before we get into that, though, just a couple points to keep in mind in terms of our power electronics is that our efficiency is going to be very important compared to sort of more standard low current, low voltage level electronics. So efficiency becomes very important. And so there's several reasons that we're going to enumerate here why it's so important. Before you do that, we can recall that in general our efficiency nu is just defined as power out divided by power in. So of course if we had 100% efficiency, which would just be a 1 in this equation, all of the power that goes in is usable power on the output. So a couple of reasons why our efficiency is so important. So why is this so important? Well, one reason is we need to worry about the max temperature of our system. And so again, we're talking about electronic systems. So we're talking about, for instance, our circuits, or maybe we're going to see later on we have some transistors, some inductors, capacitors, of course, all of these components that we're so familiar with. So why are we concerned about the max temperature of our electronic system? Well, if it's not very efficient, remember whatever the difference is between P out minus P in, so if we have less than 100% efficiency, there's going to be some non-zero value for that difference, and so the difference is just going to be heat that's dissipated in the circuit. So heat dissipated in our circuit. And so of course this can lead to poor performance, and it can also lead to reduced mean time to failure. So in general it just might not be working like we want it to, or we could have reduced mean time to failure. And so basically all that's saying is it might not work as well while it's working, and then it might stop working earlier due to some issue that's caused it to malfunction or break completely. Okay, so our temperature. So sort of related to that, and so this is a slightly different order than what it appears in the notes, but we also need to consider our thermal design in terms of our P out and P in. And so why is our thermal design important? Well, for a given P out, if we have less efficient design, we're going to need more cooling options. So for a given P out, if we have less efficiency, then that means we're going to need more cooling. And so there's different ways we can cool. A couple that you might be familiar with, of course, we can add heat sinks. So we could maybe attach some metal heat sinks to our circuit. Maybe we have some fan cooling, various things like this. But of course, this is going to get expensive as we add more things. And another thing to consider is that as we're adding, particularly if we're looking at heat sinks, maybe that's making our design more bulky, and maybe we need to have this power supply fit in a certain package that's a certain dimension, so we only have so much space to work with. So these are two other reasons why we want to have as high efficiency as possible, such that we have a less heat wasted in our system. And then the third one is just sort of related to the current climate of our sort of power systems environment. And so that's just our general energy demand from our power source. And so essentially all this is saying is, of course, we want to be less wasteful. So for a given total power that's consumed for P out, we want to have as good efficiency in general. And so this isn't necessarily related to our specific electronics component, but basically we can just say it's good not to waste. And so that's important, obviously, inherently, because we don't want to be wasteful. We don't want to be taking a lot of our P in if we're not producing a good P out. But at the same time, in terms of having a device that goes to market, like I was saying, in today's climate, everything is centered around sort of greener designs, right? So something that has a really poor efficiency might not be able to market as well as something that runs a lot more efficiently. So what we're going to do in subsequent videos is we're going to talk about power supplies in general. Later on, we're going to look at some specific DC-DC converters. And throughout this discussion, we're going to be talking about efficiency. So that's why I wanted to go ahead and bring up these 3 points up front.